Okay, on problem 1, we have one pair of angles marked. Sorry. We have one pair of angles marked. We have the sides that include angle A and the sides that include angle D are given. We have a chance to use side angle side. Now what we have to check is the smaller side 6 divided by the smaller side 9, is that equal to 8 over 12? The larger side's divided. And you can see over here that 6 over 9 is 2/3, 8 over 12 is 2/3, so we have similarity by side angle side. If the first polygon is called ABC, you're starting at the angle and going down the short side. So start at the angle, go down the short side on the other one to get DEF as the correct correspondence. Okay, on our second problem, notice first of all there are no angles marked. That means our only possible way to get similarity is going to be by side, side, side. That requires that all three pairs of corresponding sides are in the same ratio. Well, the correspondence will be the smallest side will correspond to the smallest. 5 over 10 is a half. But when we divide the middle side, 6 over 9, we don't get a half, we get 2/3. As a result, we do not have similarity in this case. On number 3, we have probably the easiest type of similarity, and that's angle, angle. The rule says if you have two pairs of congruent angles, you have similarity by angle, angle. So we have that. And if we call the first polygon triangle ABC, we're starting at the no mark angle and then going to the 1 mark angle. Following that same path over here would be DFE. On problem number 4, we don't have any sides, any angles marked at all. So our only possibility is side, side, side. 3, you take the smallest side 3, divide it by the smallest side 6, that'll give you a half. Take the middle size sides, 4 and 8, divide them, that's a half. But 7.5 over 10 reduces to 3/4, and 3/4 does not equal a half. As a result, you have no similarity. Okay. On our next problem, the most helpful thing to do is to draw the two triangles separately. But at least we've got a big triangle on the outside, and the given information was that angle E was congruent to this angle at B, angle CBD, and angle A was congruent to this angle BDC. You can also see that the little triangle here and the big triangle on the outside also contain angle C. So they have 3 pairs of congruent angles. They're similar by angle, angle. I've taken triangle BDC, flipped him over, and drawn him down here. So he's turned the same direction as triangle EAC on the outside. They have the 3 same angles, the 2 mark, the 1 mark, and the 3 mark angles in them. So we can form ratios of corresponding parts. There's a variable x here on AE. So what we're going to say is that x over its corresponding part 8 is going to equal 18 over its corresponding part, which is this BC. Sorry, the length of BC has sort of been obliterated there. It's this 10 up here, so when I flip them over, that's the 10. So what we get is that x over 18 equals 18 over 10. When we cross multiply and solve, we're going to get that the length of AE, which is our variable x, is 14.4. Finding the length of ED, this segment here, is just subtracting 18 minus 9 gives us 9. Okay, in our next drawing we have 2 polygons that are given as similar. Since they're similar, we can find their scale factor by looking for a pair of corresponding sides with numbers on each of them. And the 20 and 24 are corresponding, not just because they look like they should be, but because when you look at the order of letters, AD's first letter and last, that's the 20. It corresponds to FI, first letter and last, that's the 24. So 20 over 24, which reduces to 5 over 6, is our scale factor. To find the value of x, we'll just take 5 over 6 and divide it by x over 4, which is its corresponding part. We cross multiply and solve, and we get 10/3, or 3.3, repeating as our value for x. We do the same thing to find y. Over here, I take that same 5 over 6 and I set it equal to 16 over y. Cross multiply and solve, and we get y is equal to 96 over 5, which is 19.2. To find the value of z, again, we're going to use that 5 over 6. 5 over 6 is going to equal 3z, we've lost the picture of the top there, equals 3z plus 3 over 4z. And when we cross multiply and solve down here, we get that z is equal to 9. Finally, we have the angles. And corresponding angles are the easiest things to do. Angles C and H correspond. They were the third letters in the namings. So just take 9W and set it equal to 99. We don't need proportions in order to do the angles. All we need to know is that corresponding angles are congruent. So if 9W equals 99, then W is equal to 11. On the true and false, two squares are always similar. Well, that's true. All of their sides are the same, so any pair of corresponding sides would have the same ratio. And all of their angles are 90-degree angles, so corresponding angles would be congruent. Two obtuse triangles are sometimes similar, but not always, so the statement always is false. You could have a skinny triangle or a wide triangle. And under the same idea, two right triangles are sometimes similar is true. Had it said always, it would have been a false statement. The two conditions for polygons to be similar, and this is exactly what I expect to see on your retest or on the final exam. Corresponding angles are congruent, and the ratio of corresponding sides are equal. Same size and same shape is nice, but it really doesn't tell us exactly what we need to search for in proving them similar. This tells us what we need to search for. Okay, in the drawings up here, we're given that triangle ABC is similar to triangle DEF. We're first trying to find the value of x. Well, this x is an angle bisector in the same way that that 28 is an angle bisector. So, since the two polygons are similar, the ratio of their angle bisectors, x over 28, equals the ratio of their corresponding sides, 42 over 36. Now 42 over 36 reduces to 7/6, so 7 over 6 equals x over 28, and we solve, we get 98 over 3, which is 32 2/3. If you want to give me a decimal, give me 32.6 with a bar over the 6 repeating, but don't round off, please. If the perimeter of DEF is 90, we want to get the perimeter, DEF is 90, we want to get the perimeter of ABC. Okay, well, there's our scale factor, 7 over 6. That was working left over right. So if I want the perimeter of ABC, I'll let that be a variable here. 7 over 6 equals x over 90. The perimeters are in the same ratio as any pair of corresponding parts. When we cross multiply and solve, we get 105 for the perimeter of triangle ABC. The segment with length 28 is an angle bisector. You can tell that because of the two equal angles. Okay, if we're going to enlarge a photo by 135%, just convert the 135 to 1.35 as a decimal and multiply. That's 64 times 1.35 is 86.4 centimeters. It's possible to do it other ways. For those of you, if you like proportions and want to do one of those, you could say that perimeter is to perimeter, 64 is to x, as the original 100 is to the enlargement 135. Cross multiply and solve, you'll get the same answer. Okay, we've got a little ratio question here. There are 21 apples and 28 bananas, so the ratio of apples to bananas is 21 to 28, which reduces to 3 to 4. Please reduce your scale factors to lowest terms. Miss Baker wants to make a really big batch of apple pudding. She has 75 apples to use. Well, we know the ratio of apples to bananas is 3 to 4. So that was apples to bananas. And she has 75 apples. We want to know how many bananas. So if we solve this proportion by cross multiplying, we'll get 3x equals 300, and we'll get x is 100. Okay, the angles of a triangle are in ratio 2 to 3 to 4. Well, what we've done on this problem is that we've always said we're going to just tag an x onto each part of your ratio. So you're going to have 2x plus 3x plus 4x. Those will be your three angles, and angles add up to 180, so equals 180. When we solve that, we're going to get x is 20. The question is, what's the largest, which is misspelled, but I think we all figured out that was largest. What's the largest angle? Well, it would be 4 times our answer of 20. It would be 80. In order to get our answer down here on number 29, you use the mid-segment theorem. Remember, in the mid-segment theorem, the length of the mid-segment has to be doubled to equal the third side. So 2x will equal 90, and x will equal 45. Okay, we're solving a few proportions at the start of this next page. All you really need to know in this particular problem is that when we write the proportion 4 to 7, we're saying 4/7. So 4 over 7 equals x over 28 is what that is saying. You cross multiply, you get and solve this guy, and you get x equals 16. On problem number 15, I reduced the 16 over 48 to 1 over 3 to make the math easier. Now you get 3x equals 15. X will be 5. On number 16, I reduced the 9 over 21 to 3/7. Then I cross multiplied. I get 7x plus 7. When I take the 7 times the quantity x plus 1, it equals 3 times 7x. It equals 21x. Now this is where people made their mistake. We've got 7 equals 14x. You need to divide both sides by 14. And here they cancel, and you've got x is equal to 7 over 14, which is a half. And over on the right side, again, a common mistake was to take x times x and make that 2x. X times x is x squared. So x squared is equal to 64. X will be the square root of 64, which is 8. The full algebra solution is plus or minus 8, but we said x here was greater than 0. On problem number 18, finding x is the easy one. We know that if we have a line that's parallel to one side of a triangle, it divides the other sides proportionally. So we have the ratio, the proportion 6 over 4 equals 9 over x. I've got that up here. That gives you 6x is 36. And x then will be 6, which is our answer down there. In order to find y, this is usually the tricky one, when you take 6 and you divide it by y, you're dividing the side of the small triangle by the big triangle. Your other ratio must do the same thing. So 6 is to y as this 6 is to that whole side, which is that whole triangle, which is 10. So 6 over y equals 6 over 10 equals 6 over y. Y is going to be 10. A similar idea over here. These parallel lines divide each transversal proportionally. So we get 15 over 20 equals x over 24. We cross multiply and solve. I first reduced 15 over 20 to 3/4. and we get 4x equals 72. X will be 18. Number 20 is the angle bisector theorem problem. In it, here's an angle bisector. We know that because of the congruent angles. This angle bisector divides this side of the triangle into two pieces, 2 and 6, that will be in the same ratio as the other sides of the triangle, 5 and y. So 2 is to 6 as 5 is to y. We cross multiply and solve, and we get 15 for the value of y. The reason, if we start the first fraction with 2 over 6, since 2 is on the same side of the angle bisector, where my pen is laying, as 5 is, since 2 starts the first fraction, 5 will start the second. This is another mid-segment theorem problem. And what we know is that we need to double the mid-segment to get the third side. So 2 times the quantity, 2x plus 5, equals the third side of 30. And then we solve that, and we're going to get x is equal to 5. Our last problem here uses the idea that if two triangles are similar, and here we have angle bisectors, that the ratio of their corresponding parts, no matter what the parts are going to be similar, are going to be proportional. Okay, so what we have, A and D are angle bisectors that are coming from corresponding vertices. The 6, here's where it says read carefully. Okay, we're going to take x over 12. That's pretty clear on the angle bisectors. So we're going to say x over 12, the ratio of the angle bisectors, equals 6 over, but it says the corresponding part. AB, the first two letters, corresponds to DF. We've got to take 6 over 9. And when we solve this, we're going to get that 9x is 72, and x is equal to 8. Okay, I hope that helps you as you prepare both for the final exam and for the retest, those of you taking the retest on Chapter 6.